Hello everyone, are you curious about how spaceships land on Mars? Let's explore. Landing a spacecraft on Mars is a monumental engineering feat that requires meticulous planning, innovative technology, and flawless execution. As humanity's interest in exploring the red planet continues to grow, understanding the intricacies of landing on Mars is crucial for the success of future missions. One of the key challenges of landing on Mars is its thin atmosphere, which is only about 1% as dense as Earth's atmosphere. While this thin atmosphere provides some aerodynamic drag to slow down incoming spacecraft, it is not sufficient to allow for a traditional parachute-assisted landing, as would be the case on Earth. Consequently, landing on Mars requires a combination of techniques to safely deliver spacecraft to the surface. The entry, descent, and landing sequence for Mars missions typically begins as the spacecraft enters the Martian atmosphere at high velocity. The friction generated by the spacecraft's entry heats up the surrounding air, creating a fiery plasma sheath around the vehicle. To withstand these intense temperatures, spacecraft are equipped with heat shields made of materials such as carbon, phenolic, or ablative materials, which absorb and dissipate the heat. As the spacecraft continues its descent through the Martian atmosphere, it relies on a series of parachutes to slow down further. These parachutes are deployed in stages, with each one progressively reducing the spacecraft's speed as it descends toward the surface. However, parachutes alone are not sufficient to slow the spacecraft to a safe landing speed due to the thin Martian atmosphere. To achieve the final descent and landing, most Mars missions utilize retro-rockets or propulsion systems to provide the additional thrust needed to safely touch down on the surface. These engines are typically activated in the final stages of descent to slow the spacecraft's descent rate and ensure a soft landing. One of the most innovative landing techniques used for Mars missions is the sky crane method, which was famously employed during the landing of NASA's Mars rover Curiosity in 2012 and its successor, Perseverance, in 2021. In this approach, the rover is lowered to the surface on cables by a descent stage equipped with retro-rockets. Once the rover touches down safely, the cables are severed, and the descent stage flies away to a safe distance, preventing any potential damage to the rover. In addition to the challenges posed by the thin atmosphere, landing on Mars is further complicated by the planet's rugged terrain and unpredictable weather conditions. To mitigate these risks, mission planners carefully select landing sites that offer a balance between scientific value and safety. Factors such as terrain roughness, elevation, and slope are taken into account to ensure a successful landing. Despite the numerous challenges, landing on Mars has become increasingly routine, thanks to advancements in technology and decades of experience gained from previous missions. Each successful landing brings us closer to unlocking the mysteries of the red planet and paving the way for future exploration and potential human settlement. In summary, landing a spacecraft on Mars is a complex and challenging endeavor that requires a combination of innovative technology, precise navigation, and careful planning. By overcoming the obstacles posed by Mars' thin atmosphere, rugged terrain, and unpredictable weather, we can unlock the secrets of the red planet and continue to expand our understanding of the solar system. Thank you for watching. Please follow for more related videos and see you later. Goodbye.